Going to take a look at two problems with polynomial long division. Again, this is integrated 3, and we're looking at 3.5. Thanks for being here. The section started off with throwbacks that you might have seen, where you might have division like this with your divisor of 10, your dividend of, let's say, 120, and you kept thinking what times 10 would get you 120. So maybe you looked at this and you were like, well, sectioning off just the first number, you can't multiply 10 by anything to just get 1. So then you opened up your horizons and then you looked at these digits and you're like, well, I could get 12. There's one version that goes in. So really that's saying at the least you can have 10 versions of 10 in here, and then you deduct the 10 versions of 10. Recall that this 100 is the 10 that was your divisor times the 10, which is part of your quotient. And then you would deduct accordingly, and then you get 20. So then you looked at this again, sized it up, and you're like, well, I could have 10 versions into 20, 2 of them in particular. So then you would deduct 2 versions of 10, getting your remainder of 0, getting your quotient to be the sum of 10 and 2, which is 12. So what this is saying is that if 10 had to multiply with 12, that would then get you 120. Capiche? And that's kind of the same idea that's happening here with now saying x plus 1 needs to multiply with something and get us to this x cubed minus 3x squared plus 6x plus 11. And a lot of the terms may seem as if they're coming out of thin air. Key thing, thin air. So on this Edpuzzle, it's like thin air. And now you have to kind of think of like the first term here is x. So on the sidelines, maybe you think if I have this x, again, this is part of your divisor. What does this x have to multiply by to get the first term in your dividend? This x cubed. Take a moment, think about it. And hopefully you're saying that it's x squared. So how does that help us? This says that part of our quotient will have x squared, but we need to now deduct that product of x squared with our divisor of x plus 1. And you did this multiplication before. So if you want to call these the steps, this is what I'm doing. So I need to deduct this product, which eventually is x cubed plus x squared. So I'm putting that in here. Notice how I'm subtracting all of this. Feel free to rewrite this if you want to. You could rewrite this step as plus a negative version of x cubed and a negative version of x squared if you want. But I just kind of treat this as is because I've seen this a bunch, but feel free to rewrite this if you'd like. So the x cubes cancel. Negative 3x squared minus x squared is negative 4x squared. And so now that was pretty much what I've called round 1 of the problem. So take a quick second to breathe because there's more. So now in round 2, you're kind of back to this x. Again, this is part of your divisor, multiplying with something that you have to think about. So yeah, you have to think here, sorry. What times this x will get you negative 4x squared? So take a moment, think about that. But I'm pretty confident it's going to be negative 4x that you need. So now continuing our quotient, minus 4x. Feel free to rewrite the plus 6x and plus 11. And now we need to deduct that product of this negative 4x with our divisor x plus 1. And that should be negative 4x squared minus 4x. So that's what's going in here. Capiche? Again, feel free to rewrite this if you want to say that this is really the addition of a positive 4x squared and a positive 4x. You're more than welcome to. This is just a quick hack for subtraction of an entire polynomial. So eventually this cancels, which is good because if this term doesn't cancel, something's off. You now have 6x minus negative 4x, which is 10x. And the 11 didn't get any attention. No love for 11. So 11 just rewritten. So that's the conclusion of round 2. Round 3, you're thinking what times the x in your divisor gets you the 10x. Notice how I don't care about the 11. I don't care about the 1. I just keep going back to this term here, the first term in your divisor. So hopefully here you're saying that this has to be 10. So positive 10 in particular, you're now subtracting 10 times x plus 1. So again, this is 10x plus 10. This cancels. 11 minus 10 is 1. And you're done. Why are you done? Because, I don't know, can you think of anything that x would have to multiply by to get positive 1 without including a 1 over x? I can't think of anything. So to summarize this work, this is your quotient. This is your remainder, which I'm just going to call R because I'm lazy. And to summarize this work, you can write this in what's called a multiplication statement. So how does that look? This is summarizing and saying that if x plus 1 were to multiply with x squared minus 4x plus 10, that would get you very close to your dividend of x cubed minus 3x squared plus 6x plus 11. But recall that you need to bring in an additional 1. So this is the first multiplication statement that would summarize the work. And the second one's going to look very similar. You honestly just rewrite most of this. So still x plus 1 with parentheses, x squared minus 4x plus 10. But now you can rewrite your remainder as 1 over that divisor of x plus 1. And then you can say that that would equal that original dividend of x cubed minus 3x squared plus 6x plus 11. Notice how I literally rewrote most of the same idea, just showing it a little bit differently, where this quotient is in parentheses and remainders on the outside, just being added or subtracted. And then down here, notice how this is the quotient plus your remainder over the divisor. This is kind of a throwback to what you've seen division shown as before. Hope this helps. Please answer the questions and get your points for today. Thank you.